The Leave plan of space experts has found that utilizing our new $10 billion toy, it will be years before that venture turns into a reality. If it goes as planned, the excursion to Proxima B will take around 20 years. So reasonably, it will be a very long while before we can confirm if there is for sure life on that planet. The age-old inquiry of whether we are genuinely alone in this universe continues. The James Webb Telescope has found some frighteningly humanesque things far away from Earth that lead us closer to the response. Our quest for life outside of us has been wild throughout each human civilization, to such an extent that we have a great many media writings and hypotheses regarding this matter. Our marvel with respect to our place and forlornness in the universe has been consistent, as though it is imbued within us to constantly look for a friend, no matter how outsider-like we may be. We may be getting increasingly close to the responses we really need. However, are they really the responses we are searching for, or are they substantially more unnerving? Join us as we explore the most recent revelations in the realms of universes and planets on the journey to track down something we probably won't be ready to observe. Lights a long way off have led researchers to find what could be the most weighty disclosure in history. Back in 2021, when the James Webb Space Telescope was scheduled to send off, a very interesting theoretical inquiry was raised about the capacity of our technology. The inquiry was whether, in the future, our telescopes could identify counterfeit light on another planet, such as Proxima B, the nearest exoplanet to Earth. Proxima B, around 4.25 light-years away, was accepted to be perfectly locked with an extremely durable dayside and nightside, like our moon. A theoretical, innovative civilization on Proxima B could move intensity and power from the dayside to the nightside utilizing photovoltaic cells that produce power from starlight. In a paper with Manas B. Lingam as one of the analysts, it was shown that huge inclusion of the dayside by sunlight-based chargers could be distinguished with future telescopes. Since JWST was more advanced, it would permit us to expand our search for counterfeit lights to tenable exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope makes it conceivable in 2024 did just that. Utilizing its higher responsiveness and more prominent range of abilities, the JWST could have found the lights we were looking for and potentially heaved us into another huge flood of human advancement. Overall, let us jump into the universe of planets and exoplanets to figure out how this was indeed even conceivable. James Webb's mission investigates Proxima B's secrets. Since forever ago, people have pondered the idea of the universe, what we are, where we come from, and where we go. These are normal yet very troublesome questions that humanity has attempted to answer since we acquired consciousness. Now, in the period of outstanding mechanical advancement, one contemplates whether we are any nearer to responding to these inquiries. If you were to ask a savant, he could say we are still at level 0 of understanding ourselves in the universe. However, ask a cosmologist exactly the same thing and watch him bounce all over in fervor as he races to let you know the most recent revelations people have made about the universe using their clever instruments. These devices, albeit not given a lot of consideration by the typical public, are straightforwardly a manifestation of human advancement itself. We now have the world readily available, and it is time we push ahead and get the universe readily available too. One such method for doing that has been reasoned by researchers and space experts through the innovation we equip. A particular formation of that innovation is now liable for the new disclosure of what may be light on an alternate planet light-years away. Yes, we're discussing the James Webb Space Telescope. The James Webb Space Telescope is the creation conceived out of the inheritances of human campaigns into space to answer a few at any point present inquiries. Are we alone? Who's out there? Where do we start and where do we end? This infrared space science device has previously started addressing these inquiries. Despite the fact that, to some degree, first you could get yourself asking what Proxima B is. Proxima Cent B, or just Proxima B, is here and is referred to as Alpha Centauri. It is a super-Earth exoplanet and circles an M-type star. Super-Earths could befuddle you, but don't stress. This text will subdue all your consuming inquiries. Super-Earths are a class of planets that are more gigantic than Earth but lighter than ice giants like Neptune and Uranus. They are truly one of a kind and can be comprised of gas, rock, or even a blend of both, with sizes varying from 2 to 10 times the size of Earth. They truly put the super in Super-Earth. Concerning Proxima B, it is a super-Earth and an exoplanet, meaning that a planet crosses outside the local planetary group. The absolute first conceivable proof of an exoplanet was seen as early as 1917. Despite it managing to work up little interest and acknowledgement anyway, in 1992 the first affirmed discovery happened, which left researchers puzzled. Another exoplanet, first distinguished in 1988, was affirmed in 2003. As of April 1, 2024, there are 5,653 affirmed exoplanets in 4,161 planetary systems. Out of these, 896 systems have more than one planet. These grand revelations are circling an M-type star. To make sense of the M-type star, you need to grasp the red dwarf. A red dwarf is the littlest sort of star in the main sequence, hence the name. In the adjoining districts of the Sun, red midgets are by a long shot the most widely recognized type of star to be tracked down in the Milky Way. They have extremely low luminosity, and since luminosity is one of our fundamental apparatuses for planet identification and different sorts of derivations, red midgets are not excessively simple to notice. These subtle stars have variable definitions and names depending on their temperatures and sizes. For example, M-dwarfs or M-type sequence stars yield a maximum temperature of 3000 K, subsequently getting their name and attributes. Returning to Proxima B, its mass is known to be comparable to 1.07 Earths. Strangely, it only takes 11.2 days to finish one circle of its star, contrasted with our 365.25 days. You can estimate the size of the star Proxima B is circling. Marvelously, under the measurement of the whole electromagnetic range, the star has a total luminosity of around 1.6% that of the Sun. Moreover, in the noticeable light range, its luminosity appears to dull considerably more. It seems fainter as it only enlightens 5 to 6% of the Sun's glow in the noticeable light range, discharging a fundamentally lesser measure of light energy contrasted with the Sun. More than 85% of its discharged energy is as infrared radiation, circling about 0.045 to 0.056 solar masses from its star. Proxima B's revelation was declared way back in 2016. You may ponder why Proxima B, with a great many stars, planets, and cosmic systems, is so focused on this specific divine body. Well, there are a couple of reasons that add to the distinct fascination space experts have in this spot. First and foremost, Proxima B is the nearest known star to our Sun, and by definition, albeit 4.2 light-years is a major number to us Earthlings, in the grand plan of the universe it is a simple blip. Thus, Proxima B, our nearest known star, is high up on the need list. At the moment, it is also a piece of the triple star framework called Alpha Centauri. Furthermore, despite Proxima's luminosity being extremely low, the actual framework appears as quite possibly one of the most brilliant heavenly bodies in the night sky, as it were, behind two others called Sirius and Alpha Centauri. Anyway, the most intriguing thing about Proxima Centauri B is that it could possibly be livable since it falls under the habitable zone. The potential outcomes surrounding the star are interminable, and in this manner, space experts have taken on the campaign to investigate the profundities and limitations of the capability of the star. That is where the James Webb Space Telescope comes in. The four vital objectives of the JWST are to look for light from the primary stars and universes that formed in the universe after the Big Bang, study world arrangement and advancement, grasp star and planet arrangement, and concentrate on planetary frameworks and the starting points of life. As the JWST continues its investigation of the said exoplanet, we get increasingly close to the finishing of these missions, from looking for exoplanets to looking for outsider life. So what precisely is said, one could inquire, taking into account that people have forever been an inquisitive species, jabbing and nudging into literally every conceivable thing that moves and doesn't move. It makes sense that a mission like SETI came into presence on such an enormous scope. Envision that God has coordinated a terrific vast expedition but with a bend, all things considered, of gold. We are entrusted with being on the post for signals, more specifically electromagnetic murmurs from civilizations beyond anything we could ever imagine. SETI, short for the search for extraterrestrial intelligence, is like the world's most high-stakes round of hide-and-seek, with our planet as the seeker and the tremendous universe as the apparently endless hiding spot. It is one of those fields where researchers are cutting-edge Sherlocks, tuned into radio waves and scouring for that subtle hello from a different universe. We are not in good company. This round of astronomical snooping started decisively in the 1960s. Frank Drake, a man who could make even Einstein say, "Well, that is a shrewd treat," pointed a radio telescope at two sun-like stars and tuned in. Despite the fact that he was welcomed with the sound of quietness, Drake's equation, a logarithmic recipe to gauge the quantity of civilizations in our universe, set up for ages to come. Fast forward to now, and SETI has abandoned a lawn science project into an interstellar undertaking. Researchers utilize a variety of apparatuses, from the giant Arecibo telescope to the Allen telescope array, an organization of dishes that looks like a cutting-edge crop circle. The point is to get that one particular sign, a blip or a murmur that makes proper acquaintance from a different universe. These are radio transmissions that SETI regularly chases after, the kind you could hear on your FM dial, just with a touch more stardust. Yet, in 1977, a sign named WOW was gotten. It was a radio burst so particular that it made the cosmologist who thought that it is exclaim wow. In the edges of the information printout, was it ET calling home? Not exactly clear, but it filled the enthusiasm to keep the ears of our monster dishes open. However, simply listening isn't enough any longer. With advancements in technology, SETI now searches for technomarks, indications of innovation, the kind that would show a human progress sufficiently advanced to produce them. Picture this. An exoplanet washed in the sparkle of city lights or canvassed in sunlight-based chargers sparkling under an outsider sun. SETI's New Age journey is to spot these counterfeit lights or modern contaminations in outsider environments. An outsider world, like finding sweet wrappers abandoned in a vast park. These endeavors tie imperfectly with the James Webb Space Telescope's mission. The JWST, with its sharp infrared vision, could be the inestimable analyst that assists SETI with spotting these technomarks. It's a tag team of sorts where the telescope views the planets, and SETI tunes in for the indications of intelligence. SETI, albeit aggressive, faces its fair share of difficulties. Space is stunningly tremendous, and signs can be pretty much as tricky as tracking down a needle in an intergalactic haystack. There's likewise the inestimable speed limit. Signals from human advancements a large number of light-years away would take eons to contact us. Yet, in spite of the chances, the search proceeds, energized by the possibility of one day figuring out that in the grand astronomical show, we are not the only players. The new revelation utilizing the JWST may very well be the greatest find in this hide-and-seek game. This momentous disclosure might suggest that Proxima B has counterfeit lights on its dark side. Anyway, what does that actually mean? Does it infer that a development sufficiently insightful to utilize instruments like our own exists? Have we found companions? Are we really alone in the universe? The general thought of this disclosure is startling, as there is quite a lot more to advance. But more significantly, the perpetual number of potential outcomes is the genuinely startling part. We should delve into the subtleties and see precisely what this implies. Envision a speculative situation. You are gazing toward the night sky, looking at a far-off planet through the focal point of the James Webb Space Telescope. As you peer further into the haziness, you spot something that ought not to be there. Faint glimmering lights dabbing the evening side of Proxima B, a planet circling the closest star to our Sun, Proxima Centauri. These lights are not irregular. However, they appear in designs too regular to even think about being natural. Could this be proof of an outsider civilization? The speculation that these lights are counterfeit in origin originates from a psychological study directed in 2021. The thought was basic yet significant. If there were a technological civilization on Proxima B, particularly one on a tidally locked planet, how should they enlighten their dim side? In the case of Proxima B, it is tidally locked, meaning one side ceaselessly faces its star while the other remains in everlasting obscurity. This situation would require the exchange of energy from the day side to the evening side, maybe through photovoltaic cells creating power from starlight. Distinguishing such a course of action with current or not-so-distant future telescopes was initially a hypothetical activity. However, the capacities of the James Webb Space Telescope, launched in December 2021, have transformed hypothesis into potential reality. The JWST's advanced instruments, especially its near-infrared camera, NIR-CAM, and mid-infrared instrument MIRI, are designed to identify faint signs from divine objects. These instruments permit stargazers to notice exoplanets in uncommon detail, possibly uncovering fake lights or other indications of innovation.